Okay, so welcome to lecture series on air pollution and atmospheric chemistry. This is lecture 8. In this lecture, we are going to do some calculations and some of the examples, numerical questions we will be solving, because this is very important topic that we need to understand. So, for example, I gave just one simple questions: calculate molecular weight, density, number of molecules per unit volume at STP, and then calculate total mass of the atmosphere. These are the few assignments questions that we will learn today, and then we will see that how ozone Dobson unit is used for representing the stratospheric ozone, and then some of the calculations like sulfur dioxide concentration is given in microgram per cubic meter. How will you convert it into ppm? Okay, so just the basic, all the crux of these equations are that we are dealing here with, actually when we are dealing with the G plus G system, then we will always be using this equation Pb is equals to nRT. This is the equation that we have to use. Now, here n is equals to number of moles. So, it can be written in principle by mass divided by molecular weight. Okay. Now, once you have this one, once you have this mass upon molecular weight, you can actually calculate and then again this equation can also be written number of atoms or molecules or ions divided by Avogadro number. So, this, remember this equation. These are the two things that very important that are going to be here actually. So, for example, if I just put this equation as a n by Na, so I can write n upon V is equals to it will be like n upon V will be equals to P upon RT, and you multiply by Na, okay, because this just arrange the equation. If you are not able to understand, just let me put this equation again. So, we will write Pb is equals to n upon Na into RT, and these equations then I can write, I can actually take n here, and V, n by V is equals to P upon RT into Na. Okay, so this is the equation that we are using. So, now let us go back to these calculations. So, if we use these equations, and I have done the calculations for you. So, if you see this table here, temperature I have taken 273.15 because we usually do gaseous calculations as STP, pressure as 1.01350 into 10 to the power 5 Newton per meter square, and then you can just calculate R into T. R is actually 8.314 into T will be temperature. So, you take 273.15. So, this will be 2270.96, something like that, and then if you just take P upon RT, then P upon RT will be 44.6, and Na upon P by RT will be 2.68 into 10 to the power 25. 2.68 into 10 to the power 25. Okay. Just if you see here, it will be actually 6.88. So, you can just write 2.69 to 10 to the power 25. Now, this is actually number that what is the volume unit of here? Remember, this is very important because we are taking all the things calculations into SI units. So, here the volume, this unit will be actually number of molecules per meter cube. This is very important. So, if we do this one, so we have actually n by V is equals to 2.69 into 10 to the power 25 molecules or atoms or ions, whatever you want to write, and then divided by meter cube. Now, this is one way to calculate this number. Remember this number, because this is very important when we are going to do calculations for Dobson unit. So, similarly, I give you another very important example to calculate this will little bit easier. How we will do? Okay. So, we know that 1 mole of any gas, it is GAS, is equals to 22.4 liter, and if we just do this one, 22.4 into 10 to the power 3 centimeter cube. Because why? Because 1 liter is equals to 1000 cc. We know this one. Okay, so 1 liter is equal to 1000 cc. 1 liter is equal to 1000 cc. So you can calculate this one. Now, from this one we also know that 1 of the mole of the gas is actually contains Na, Avogadro number of molecules in this one. So Na is actually, what is that? Na is 6.023 into 10 to the power 23 molecule per mole. Okay. So now you can calculate that how many molecules will be there. So if you just calculate 6.023 into 10 to the power 23 divided by 22.4 into 10 to the power 3, this is not the unit, this will be in centimeter cube, and this will be actually, if you just divide this 6 and 22, so it will be little bit, because you are dividing by 22 and this, so 2 thrice are 6, so it will be little bit like 2.69 into 10 to the power, now you have to see here it is 10 to the power 20 hot molecules per centimeter cube. This is important here. Okay, so just small calculations again you have to do, because I calculated that we got the number 2.69. Oh, sorry, it is will be because you have to divide by 22, so it will be 10 to the power 19 actually. Okay, because one decimal will go from here, 6 upon 22. So 10 to the 23 and 3 will be from 23. You can just subtract 3, so it will be 20, and 6 upon 22, so it will be 2.269. so you just write it actually, so it will be like 2.69 into 10 to the power 19. Okay, molecules per centimeter cube. This is for centimeter cube. So there are 3 things that you have to remember. One, if it is asked, if you have been asked to calculate in molecule per centimeter cube or molecule per meter cube, because we will go to now next calculation of Dobson unit. Okay, so we know Dobson unit, what we do, the calculation is done here, that in the Dobson unit your concentration, one Dobson unit is defined as 0.01 mm, okay, thickness of ozone at STP. Okay, now this is very important. So what you do, 0.01 mm. So this means if you take all the ozone layer, you can see the vertical column, and you compress all the ozone into a slab, the thickness in such a way that the thickness becomes 0.1 mm, then all these things will be called as one Dobson unit. So one Dobson unit is actually like, and you can from there you can also calculate that one Dobson in 0.011 mm is again 10 to the power minus 1 centimeter, right? And we also know that one at STP how many molecules are there? There are actually 2.69 into 10 to the power 19 per centimeter cube. This is just calculated, just minus. Okay, so it will be like 2.69 into how much will be 0.01 from there and 0.01 from there. So okay, so it will be actually 10 to the power 16 molecules per centimeter square. So this is actually called Dobson unit. Okay, so this is very important. Okay, and from the one more equation from here you can also see that one Dobson unit is 0.0 mm. So what would be thickness of 1 mm? Okay, so it will be 100 Dobson unit will be equals to thickness 1 mm thickness. Okay, so you can calculate this one. This is very important. So we will go to the next question. So remember, there are the few equations that we have to remember. One Dobson unit is equal to 0.01 into how much? 0.01 millimeter ozone at STP, and it is same actually like 2.69 into 10 to the power 16 molecules per centimeter square, or if you just calculate into per meter square, then it will be 2.69 into 10 to the power 20, because you just see meter and centimeter, there are actually 10 to the power 2, order of 2, so it will be 4. So 16 plus 4 will be 20, or 20 minus 4 will be 16. So this is actually very important, and 1 millimeter thickness of ozone at STP is actually 100 Dobson units. So you can also remember this one, or you can also retain this is very important for conversion. Some of the objective questions are asked in the on this one. 1 Dobson unit is also equivalent to 1 mm atmospheric centimeter. This also you have to remember, because you have to put the pressure and calculation on this one. Okay. Then will come. Okay, now another equation you should remember. So this is, I said about converting ozone concentration in Dobson unit, converting into molecules per centimeter square, or converting into thickness actually. Okay. Then if you are talking about gas to gas, one more thing is that you have to remember that microgram per meter cube. If you have to report concentration of any gas species X in microgram per cubic meter, you just remember this 40.9 into molecular weight of the compound into its concentration in ppm. This is very important. Just remember this equation. If you want to see this one, we can go back and see the calculations there, because the calculation was here actually, P upon RT, yeah, it's here. Okay. So what you see here, P upon RT, because we have to calculate P upon RT, how much it is? P upon RT we calculated is equals to 40.9, and this 40.9 will be going to the there, and because this equation can be written, we have this equation, Pb is equals to nRT. You can write Pb is equals to n is mass divided by capital mass molecular weight into RT. Now from here, if you want to write concentration m upon V, okay, it can be written as P upon RT into molecular weight. Okay, and then you will have the concentration of ppm, because you have to use 10 to the power minus 6 there, and then P upon RT is actually 40.9 if you calculate, and then you have molecular weight, and then you have a ppm. So just remember these equations. Then that if you have to report the concentration in microgram per cubic meter, you have to remember this equation. This is very important equation. Okay. So we will do some calculations here. Okay. So the first question is, for example, the thickness of ozone layer is 3 mm at STP. Calculate the abundance of ozone in molecules per centimeter square. Now you have this is what is actually happening. We know that if the thickness is, you can calculate, if you know that how much is actually like molecular concentration, it is 2.69. Okay, let me write here, 2.69 into 10 to the power 16 molecule per centimeter square, and you just multiply by how much? 3 millimeter thickness. So 1 millimeter is 10 to the power minus 6. So means you have to multiply by 3. You have to multiply by 0.3 again. Okay. So you have to multiply by 0.3. So it will be calculations. You can do the calculations. It will be 7, 9 into and 0.697 something. No, this is calculation is not correct. So it will be 3 9 जा 7 and 3 से 18 और 2 20 और 3 दिन नीचे और एक 7, 0.7 into 10 to the power minus 15 like that. So you can just calculate these things. These are very simple things. Another calculation is that calculate the concentration of SO2 at 25 centigrade Celsius and 1 atmospheric pressure is 80 microgram per cubic meter. What is the concentration of SO2 in ppm? Okay, so here you have to remember that the equations, what equations we had? We had the equations as microgram per meter cube is equals to what? 40.9, that was the conversion unit, into molecular weight into ppm in concentration. Now you know what is the molecular weight of SO2. SO2 is actually like, sulfur is 32 plus 16 into 2, so it will be like 32 plus 32 will be 64. Okay, so now you put the equation in the equation, you have to calculate in the ppm. So the value will be 80 divided by 40.9 into 40.9 into how much? 64. Okay, so this will be the concentration. And if you just do this calculation, you take this as a 40, if I just take approximation this as a 40, so it will be 2, okay, and if I just take 1, 2 and then it will be 32, so 1 upon 32, something like 1 upon 32 and 1 upon 32 will be equals to 0.03. So this will be your concentration. So just remember this, that the calculations are very important. It is in the papers you will read that sometimes numbers are given in ppm, sometimes number are given in microgram per cubic meter. So this is very important, and we must understand that you always remember that microgram per cubic meter concentration will be numerically higher than the concentration in ppm. Because why? This simply because any gaseous species, the molecular weight of the gaseous species will be more than 1, and we have another factor of 40.9. So 40.9 into molecular weight times the ppm concentration will be equals to the concentration in microgram per cubic meter. So this is very important. These are the two things that you have to remember. So the concentration, if you are reporting in microgram per cubic meter, it will be higher than the concentration of if you report the concentration in ppm. Now how much higher and how much lower, it will be depending on the molecular weight only, right, because this is the only thing that is variable here. Okay, so let's go and do some another calculations here. The calculation is very simple. I will give you very tricky things here. Calculate the molecular weight, density and number of molecules per unit volume. One clue I have already given to you all. One clue I have given that 1 mole is equals to 22.4 liter. This means 1 mole is actually 6.023 into 10 to the power 23 molecules, okay, and will be equals to 22.4 liter into 10 to the power minus 3. You have centimeter cube per liter, so liter will be going away. So from here you can calculate N by V, that we calculated will be equals to 2.69 into 10 to the power what was that, 23 and then 10 gone from the 10 to the power 3 gone, 19 it was, yeah, it was 19, okay, to 2.69 into 10 to the power 19, 2.69 into 10 to the power 19 molecules per centimeter cube. Okay, this will be the concentration. Another one is calculate the mass of the calculate the molecular weight, average molecular weight of the air. So you have to just do what you have to do, because we know average molecular weight of air will be equals to, what is that, 0.78. Now you have to use your mole, otherwise it will be very difficult. So 0.08 into N2 is 28 plus 0.21 into oxygen is 32. Oxygen is 32 plus you just have 0.9 into what is that, nitrogen, oxygen and argon. So argon molecular weight you have here 39.9. So you just calculate, this will be actually somewhere around 28.97 gram per mole. This is very important. Okay, so you can do this calculation as well, that how much is actually gram per mole. Now density, if you have to calculate, again remember that this calculation becomes easier if you use the volume. So 28.69 is the gram per mole, and 1 mole volume is actually 22.4 liter. So it will be actually, if you just calculate this one, you can write 28.97 divided by 22.4, and this is gram per mole, just remember the unit, and this is volume is liter per mole. Okay, so this will be the density about 1.29 gram per liter. So just see how easily we can calculate the density and all these things. One last question that we will do today is calculate the mass of the atmosphere. So there are two ways you have to calculate. Either you have to calculate integrate all the things in the atmosphere, or you simply use very important concept, pressure is equals to force by area. And what is the force? Force is actually, suppose the mass of the atmosphere is m, then it is under gravity, so force will be m into g, and area, what is the surface area of the earth, is actually 4 pi r square. If you just use this equation, and now we know that atmospheric pressure is, what is P? P is actually 1 atmospheric pressure. This means 1.01235 10 to the power 5 watts per meter square. Okay, this is the pressure, and then gravity we already know 9.8 meter per second square, and r is given there. If you just go back to the previous slide, r is given 6378 kilometer. Okay, so we have to just remember this one, otherwise it will be very difficult. 6378 kilometer. Now you cannot use kilometer here, you have to use in meter. So it will be 6378 into 10 to the power 3 meter. This means you can again write here 6.378 into 10 to the power 6 meter, and then therefore you can calculate 4 pi r square. From here 4 4 into pi, you can use 22/7 into 6.378 into 10 to the power 6 ka, it will be cube of that one, because square. Okay, so you can just calculate this number, you will have this number, some calculations, and you use the g. So just put these numbers, you can calculate mass of the atmosphere. So this is actually, we know this one, and then mass of the atmosphere can be very easily calculated. So just there are few things that you have to remember. Calculations becomes easy if you know the units, otherwise if you do, sometimes it becomes easier if you calculate traditional way, or if sometimes it becomes more easy if you just use the concept of the moles, that 1 mole contains this much and 1 mole is equals to 22.4 liters. So you have to remember, what you have to remember here, that 1 liter is equals to 1000 cc. This you have to, this conversion unit you have to remember. And then we also know one thing is very important, 1 cc is actually 10 to the power, 1 centimeter cube is actually 10 to the power minus 3 what? 1 centimeter is 10 to the power 1000 cc. Centimeter cube means 10 to the power minus 1. What I am doing here actually. So this is already cc, so you can already put it number of molecules in this one. I wanted to calculate in meter cube. So 1 meter is equals to 10 to 100 cc. So this means 1 cc is equals to 10 to the power minus 2 meter. So 1 cc cube, centimeter cube, will be 10 to the power minus 2 meter cube. So 10 to the power minus 6 meter cube. So if you have to see this one, you just put this here, 1 centimeter. So 1 liter will be equals to 10 to the power minus 3 what into 10 to the power minus 6 meter cube. So this will be 10 to the power minus 3 meter cube. This meter cube actually is, if you use liter or meter cube for the case of air or atmosphere, then these are same. So actually 1 liter, you have to remember that 1 liter is actually 1000 cc. At the same times 1 liter is actually 10 to the power minus 3 meter cube. This is a small things that you have to remember, and then based on that you can calculate. So again you can see the calculations that how are done, I have given here actually. So if you have just to report, sometimes what happens, just to confuse you, the numbers are given in terms of molecules per centimeter square, sometimes it given molecules per meter square. So you have to remember which unit actually you have been given. So just remember these things, do some calculations as I suggested, otherwise it will be very difficult. Just remember this equation, microgram per cubic meter is actually 40.9 molecular weight into ppm, this one thing. And then if you have to again remember that STP means standard temperature and pressure, 0 degree centigrade and and then 1 atmospheric pressure, and when we report the concentration into atmospheric or ambient condition, we usually take standard temperature as 25 degree centigrade and 1 atmospheric pressure. Another very important thing that you have to use, that when you if you suppose you are reporting this concentration at the ground level in say Gangetic plane, then you do not need to have the calculations, but if you are using at the higher altitude sites, then you have to use the correction due to the gravity as well actually, because the concentration will be different in the higher altitudes. So, I think this is what we had today, and I thank you for again this one. Just remember this concept is important. I am not very habitual to kind of this online teaching. So, this is sometimes writing becomes very difficult, and then lots of things get messy. But what is important is that you have to actually use these things, you have to understand, and you have to develop your concept properly in order to make sure that you understand things. So, thank you. I will stop here.